Hello, so today we are doing this problem called add even linked list, and the problem says we get a single linked list and we want to group all nodes together followed by the even nodes, and all add nodes first and then followed by the even nodes. And here the adds and the even concerns the node number or the index of the node, considering that we are starting to count from index 1, so it doesn't start from 0, it starts from 1. And any node that has number odd, we're going to group it with the odd ones, and even with the even numbered ones, and not the value. That's an important distinction. And we should do it in place on the same linked list, and it should run in O of 1 space complexity and O of the number of nodes time complexity. And what we want, and the additional constraint, is that the relative order inside both the even and the odd group should be the same as the original linked list. And so since we are starting to count from 1, so the first node is of position 1 and is considered odd, of position odd, right? And then the one after it is of position 2, so it's even. The one after that is of position 1, so it's odd. The one after that is of position 4, so it's even. So you get the idea. It's kind of alternates between odd and even, of course, because it's positions parity, right? And so that's the problem we are dealing with. How can we solve it? So the first simple thing that just comes into mind right away is, okay, let's just put an I here and let's just number them, right? And just check that I. If it's positive, if it's odd, put into an odd linked list, and if it's even, put into even, and just keep track of. So we will put elements like this, right, in the even from this list, depending on their position, right? So let's say O1, O2, and just keep putting them, and O3. So in able to keep put, we need to keep a reference to the current node, right? Like this, so that on the next one we want to add, we can just say add.next is equal to O2.next, which is add.next is equal to the new one, right? So we need to keep track, and then advance add. So we need to keep track of where we are at, and we also need to keep track of the head, because later we want to return it, and we want to also later combine the odd group with the even group, so that the even group at the end of the even group the end of the odd group points to the end of the even group. That's what's happening here. We take the so let's call this odd head, and we do the same thing for even, right? We do a similar thing for the even part. Let's just call them E1, E2, E3. And we would have a pointer to the last one, to the tail, right? And then we would have even head, right? Because why do we need the heads? Because, for example, for this case, if we take this one here, let's take this one, right? And so the solution should be something like this, the final solution. Just put it down here. So why do we need that? Because, okay, let's number them in the numbering that was given. So we have 2, we have 3, we have 4, we have 5, right? This is the numbering. So once we put the evens, so we will put the evens in their place. So 1 is even. So we'll put the odds, and then we'll put the evens, right? So the odds, 1 has odd index, 3 has odd index, 5 has odd index, right? And then here 2 has even index and 4 has even index, right? And so what we want is, we want the odds group to point to the even group, right? So that we can return this as the final list, right? But to do that, we need to have a pointer to the even head, right? So that we can say, because this is the odd tail, right? So let's call this odd tail, or let's just keep it odd, but it's the odd tail. And so we want to add .next, which is basically pointing to saying 5.next here. We want 5.next to point to 2, right? Which is, what is 2? 2 is the head of the even list, right? So we need to keep track of the head of the even list. We also need the head here to return it. So when we return the head, or you can call it also add head, whichever one you prefer. We can also return head. And that's pretty much it. So we'll just use this I to keep traversing and keep increasing it to know in which group we add the element. And since we are keeping track of the tail, we can easily add the element to whichever group it belongs to. And since we set the head, the even head and the odd head, we can do this operation to connect them together, and we can return the final head. And that's pretty much it. So let's solve this problem. So we just need to take care of some base cases here, which is if the head is empty, or if the head is just one element. In those two cases, we can just return the head. We don't need to do anything, right? Because there is just one element or nothing, right? Otherwise, we need to group them. So we need the add pointer. So we need the add pointer, right? This one, which starts out as the first element of the adds, and then we need the even pointer, and then we will need some nodes just so that we can know at this position where is the current node. This will basically just allow us to know when we are done. Like, I can't tell us that we are done, but we need this pointer so that when it reaches null, we know we can stop. And so we need this pointer, it's called current. And then we need I, right? So let's initialize these values. So what add would be is just the head. That's the first one. The even would be the second one, right? So it's head next. And the current would start out as the we can just, since we already know what the first one and the second one is, we can just start our current at this position here, and then we can start I at this position, because we already know that the first and the second one are not null, because we already checked for null, and we know that this one is part of the add and this one is part of the even, so we can just start with those. And so our current will start at the third position, so that if it's null, we are done, otherwise we'll continue. And so right now I is at position 3, because we already set this one and we already set this one, and now we are at this position, right? So that would mean our I here is equal to 3, right? And we need to set the head and the even head, the odd head and the even head. The odd head is just head, the even head is just head next, right? And now we will need to keep going while we have current, while we haven't reached the end. And so what do we need to do? We need to check if I is even or odd, right? So this means it's even, right? Otherwise it's odd, and we need to handle the odd case. But our iteration step is doing I plus 1, of course, and advancing current so that we can know where we are when we are done, right? And so if it's even, we need to add it to the even group. How do we add it to the even group? Just by doing even.next is equal to current, right? The current value. But so one way we can do that, since we don't wanna keep the previous setup, we just can say even.next is equal to this node of the value current.val, right? And then we need to advance the even pointer, right? And same thing for add. We need add.next is equal to list.add of current.val, and we do the same thing, we advance the pointer. And when we get here, when we are done with the loop, that means we already grouped each in a separate group. So now we just need to connect them by saying, okay, add.next is equal to even.head, and then we can just return add head, right? And that's pretty much it. So we have a slight problem where we have a duplicate here. So where is that duplicate coming from? Yep. So here, if I keep track of the same, then its next is already the one in the list, so that won't work. So I need to instead do this, so that it's a brand new node. this one I can keep it as it is because it's just my pointer. It's not a new thing that I wanna, this new list, right? Consider here that I'm doing it not in place. That's okay for now, but I will show you in a solution next time how to make, how to do a solution that is not, that is in place, that doesn't require extra space like we are doing here. And then this one should be the evens head. Is just so just call this the odd and then even, right? Easier. It's the same thing, right? At the initialization step. And then we do grouping and then we connect them, and that's pretty much it. So we yep, so add is header val, this one is header next val, and this one is that. Yep. So where's the mistake here? Okay, this should work technically. So we are setting the header val to be the odd pointer and the header next val to be the even pointer and current to be this, and we are setting the I to be 3, and these heads starts out as odd and even, and we are checking if it's even. We are assigning to even current val, then we are advancing the pointer. Otherwise it's odd, so we are assigning odd next to the value, we are advancing the pointer. Here we're increasing I by +1 and doing current equal to current next. Okay, and then so this current here, that's the third element, so that's good. And current equals to current next, and then we are pointing add next to even head, and we're returning add head. Yeah, the problem is that this is inside the while loop. It should be outside. This is when we are done grouping, right? Okay, so that seems to work. The problem was an indentation problem, but you can see here the essential idea that we did here in this explanation here. That's what we coded up here. So let's submit this. Okay, so that solution passes, but it's not ideal. So let's see how can we eliminate needing these list nodes here. So the way we can do that is just don't create a new list. Just keep track of the, and don't keep track of I, right? But just alternate, like, right? Like say, so keep track of course, keep track of, let me just make some space here. So we need to keep track of course, we need to start these out the same way as add. So, and then we know that even would be here, right? So these are the pointers to the even, the last even spot and the last odd spots. And we need this one to be the even head, right? The first one to be even head. And then we keep progressing, right? And so the way we will do it is the next iteration odd would be here, right? The next iteration odd would be here, right? And we remove it. It's no longer here, so we advance it one step. We advance it kind of, so odd becomes, so on the next iteration odd becomes even dot next, right? That's what we did here. It's even dot next, and then the head stays the same, but the even head stays here. But the even pointer goes to add.next because that's what it is, right? Because that's the, if you look at the numberings that we have here, this is 1, 2, 3, 4, 5. The even index, even position is always the one right after the odd position, the last odd position, right? And the same thing for, so it's even is add.next. And so we can alternate this way basically and just toggle. And that's literally what integers do between, for the parity, from you've got 3, which is odd, and then you get 4, which is even, and then you get 5, which is odd. So that's how it works. So let's just do that. We still need not head because that's just the base case that we can handle here. And we need to keep track of odd and even, and we need even head. We don't need add head because that's just head, right? We can put head there, but it just head, it doesn't, no need to create an extra variable there. And so the first add pointer, it would point to head, even will point to the next one, which is head.next. And you can see now why we did this, because if we didn't, then head.next would be null and we'll have a problem. And even head would be the same thing as even, so it's just head.next. And then now we can start while we know that even is always after odd, so we can just check the even while it exists, it's not null, and there is an even.next, because if we are at the last position, like even is here, let's say there was it's here, or in a case where the linked list had a 6 an even position as the last one, then we are done, right? So what do we do here? So we know that add.next is going to be equal to, so we know to that so the new add, which is going to be even.next, right? So we know that add is going to needs to be even.next, but we need the pointers, we need to point it to it, right? So we need to point first, before doing this, we need to point add.next to even.next, right? Because that's the next add value, right? This is because we are doing it in place. So we need to connect the add.next with the, before doing this, we need to connect add.next to even.next, because that's the next add value. So we need to connect the previous add node to the next add node, right? And then same thing here, we need to connect the previous even node, which is even, and connect it as its next to the new even, which is add.next, right? And then we can do this, right? And so that would be doing this here. Yeah, so that's basically for the wiring, because at the end we want this pointer to not point to 3, but we want it to point to 4 instead, right? And so that's why we are doing this step. But we don't want to do it after, because at that point, if we do it after, at that point even became this one. And so if we say that it's .next is equal to itself, that won't work, right? So yeah. So here add is equal to, actually this is just add equal to add.next to go to the next iteration, and even is equal to even.next. So it becomes that one, because even.next, so basically why did I do this? Let me just show you this. So basically even add.next is the new, so add.next is already connected to the next even, so we did that, and so this one is just for the next iteration, right? And so this one is just the same. So this one is just even.next is add.next, and now we just go to the next pointer, make an even be even.next. So apologies for this, which probably confused things a little bit, but essentially what we are doing is at the first step, when we have add here, and so our list is in this format 1, right? And now at the next step we have even. So we want even we already had even here, right? We already had even here. And so we had even like this. Okay, let's call this add even. Okay, so what do we want? We want add.next. So add is here, the pointer of add, that's here, and the pointer for even, that's here. So what we want is we want add.next to be connected to the next of even, which is 3. So we want to have 3 here. So that means we want add.next to be equal to even.next, right? And once we did that and did the connection, we want to move our add here, right? And so that would mean we want add to be equal to add.next, which is what we have here. For this one, so we have to, we're going to connect it to 4, right? Which is add, the new add.next, right? And so we want 2.next to be equal to 4, which is even.next to be equal to, remember now our add after this operation, our add would be here. We want even.next to be equal to 4, right? So we want 2.next to be equal to 4, which means we want even.next to be equal to add.next, which means we will have this group here. And then we want to move the even here so that we can wire it up in the next iteration with the next value. So we want even to be equal to even.next, which is what we're doing here, right? And then after that, after this iteration, our even would be at 4. Our head, even head was still at the same position. And then our add is at 3. And so we do the next iteration by starting with this. And so we want to connect 3 to 5, right? And so we want to connect 3 to 5. So 3.next to be equal to 5. And so that means we want the 3 is the current add, right? And 5 is even.next, right? So the same as we did here. And then we want to, so that would mean we will have 5 connected like this. And then we want to advance this for if there is a next iteration going, right? And so at that point we do add equal to add.next again, which is the same thing we did for the previous iteration. For even, now we want to connect 4 to nil, right? So what should happen? So 4.next should be equal to nil. And so 4 is the current even, so even.next is equal to nil, which is 5.next, which is 5.next, yeah. So it's 5.next, that's null. And so that would mean it's add.next, right? Which is the same operation here. And so this one will be connected to null, and we want to move even to the next one. And now our even would be null, and so we'll exit the loop because even is null, right? And that's essentially what we are doing here. And at that point, after doing this, now what should we do? We want to connect the adds to the even. So we want to do this and connect it to this. So we want to have the add pointer dot next be equal to the even head, which is 2 here. So we want it to be equal to even head, right? So that's the operation that we are going to do next. And we want to return the add head, which is the head, just head, because we didn't assign a new variable. So that we just return head. And that's pretty much it for this solution. We just followed what we would have done by hand, right? And so let's run this. Okay, so that passes. Let's submit. That also passes. Yeah. So as for the complexity, we are just doing one pass, right? And so we are just going taking our pointers and going from the start to the finish, right? So the time complexity here is just O(n). And here we are, this solution we are doing as the problem told us, we are doing it in place. So that means the space complexity, and our space complexity here is just, we are only using 3 extra pointers, we are not using any other linked list or something, so it's just O(1), right? And yeah, that's it for this problem. See you next time. Bye.